The ground in Yellowstone does not roar. It breathes. A geyser shoots into the sky, and for one moment the park becomes an open wound in the earth. Under the visitors' feet, this is not a quiet national park. It is the most famous supervolcano on the planet. The volcano that disaster films imagine burying half of America under ash. The volcano that, in our imagination, can darken entire continents. But now another possibility is appearing. Not that Yellowstone will explode tomorrow, but that for decades, we may have been looking for the wrong culprit. The old story was elegant, maybe too elegant. It said that deep beneath Yellowstone, a mantle plume rises, a hot column from inside the earth, like a bubble in boiling water. Perhaps it begins almost 3,000 kilometers down at the boundary between mantle and core. From there, scientists thought it burns its way upward. It strikes the crust. It feeds an enormous magma chamber. And that, we were told, is why Yellowstone boils. Geysers, hot springs, trembling ground. Supposedly, all of it came from below, from the depths, from the inner organs of the planet. That was the textbook version. Beautiful, logical, repeated for decades. In documentaries, the case sounded closed. Yellowstone sits on a mantle plume. Full stop. But every good theory has an enemy. Better data. New seismic tomography began to look deeper. Not with fantasy, but with earthquake waves. Those waves travel through the earth like cracks through glass. And from their speed, a three-dimensional image of the underground begins to form. Then the old certainty started to move. Because the new modeling did not show one simple pipe of fire. If a mantle plume exists there, it may not be the main actor. Maybe it stands in the background. Maybe it supplies heat, but not the script. The real action may lie much closer to the surface. Inside the crust itself. That is the fracture in the story. Earlier, Yellowstone was imagined as a kettle on a stove. The stove was the plume. The kettle was the caldera. A simple image, almost comforting. The new view says, no, it may be more like a cracked pot, boiling through pressure, fractures, and local flows. The stove may exist, but it may not explain why the pot overflows exactly here. The leading role may belong to tectonic processes, movements of the Earth's crust, cracks that create pathways, faults that redirect pressure, local melt flows that do not have to come from 3,000 kilometers down, but from much nearer zones. That sounds smaller. It is not. It makes Yellowstone more complicated. And in geology, complexity is rarely comforting. Because if this is true, we have not misunderstood only one volcano. We may have explained an entire class of supervolcanoes too simply. Yellowstone is not alone. There is Toba in Indonesia. There is Taupo in New Zealand. There is the Valles Caldera in America. If our model for Yellowstone starts to wobble, the comparisons wobble with it. And then it becomes a question of global safety. Because supervolcanoes are rare. But when they erupt, they do not only change landscapes. They can change climate, harvests, and the sky itself. And that is why every wrong detail matters. The second problem is prediction. To this day, there is no reliable calendar for a supervolcano. We do not know which sign will be the first real warning. More earthquakes? More uplift to the ground? More gas? Or a pattern we do not yet recognize at all? If for decades we mainly asked about the plume, we may have missed other signals. Maybe we were searching below, while the decisive clues were above. This does not mean the danger is greater today. It means our sense of safety may be standing on an incomplete picture. That is the unsettling part. Not panic. Doubt. Scientists may not have been wrong by 1 year. Not by 5 years. But by decades in the basic assumption. The most famous theory about the most famous supervolcano on Earth may be incomplete. Or partly wrong. Yellowstone is not an abstract mark on a map. It is a national park visited by millions of people every year. It is a place where people live, work, measure, and wait. And if it erupts one day, the question will not be whether there are consequences, but how far they reach. Still, Yellowstone is not exploding tomorrow. That is not what this research says. It says something more disturbing. We do not understand the system as well as we thought. And once you realize that, the right questions begin. If not the plume alone, then what? Which tectonic processes feed the magma chamber? How large is that chamber, really? How fast can it fill? What is happening at the boundary between crust and mantle right now, in this second? The new three-dimensional modeling is not a final answer. It is the beginning of a new investigation. Imagine, for a second, that we could look beneath the ground. We would not find a clean pillar of fire rising from a core. We would find chaos, cracks in the crust through which melt rises, zones where pressure breaks rock and shifts it sideways, local pockets of magma that expand and contract again. Not a perfect textbook sketch, but a living, pulsing machine. It works by rules we're only beginning to read. And that is exactly where the fascination begins. We live on a planet that keeps secrets even in its most famous places, even in Yellowstone, even beneath the ground we stand on. So today, this is the image that remains. Yellowstone is more complicated than we thought. The mantle plume theory is now under serious doubt. The new 3D view moves the tectonics of the crust into the center. That does not make everything more dangerous. It makes everything more mysterious. Science is not shouting, panic. It is saying, wait, we need to look again. That is not weakness. That is the strength of science. It moves closer to the truth through doubt, through new models, through the courage to let go of a beautiful explanation. And Yellowstone keeps breathing. The geysers strike. The ground trembles. And somewhere beneath it, something is happening that we do not fully understand. Maybe that is the real terror. And maybe it is also the real reason to keep watching. Write in the comments which explanation convinces you more, the deep plume or the broken crust. And if you want more frontier cases between Earth, science, and mystery, subscribe to the channel and leave a like.